everybody? Oh, okay. Everybody can hear me? Okay? All right. So hi, everybody, and thank you, Mike, for the introduction. I am honored to be here. I was watching through past speakers, profile, and so it was great talks, great speaker, great background, and for me, actually, when I'm with people, oh, you look really young, you look like you're just fresh out of the college. Well, I am. So I'm going to talk to you today mostly about, my journey, while I was in college and how we actually spun off a robotics startup from a student project, some of the background, and where kind of the drone industry or robotics history, the industry is going to go. And some of our journey throughout the past year with being in business. So my background, my technical background, I'm actually a solar engineer. I was actually a solar engineer when I was going to school in University of Nevada, Las Vegas, and my big kind of high-profile project that really shaped me into who I am today was a project called Solar Decathlon. Has anybody here heard about the Solar Decathlon? Okay. So for those who you don't know, it's a Department of Energy hosted competition that challenged 20 teams in the world to design, build, and operate a solar-powered house. So it's a 2-year project. You take it from design, you have to build it, and you have to take your house to the competition site to compete, and then it goes through 1 month of monitoring and stuff, and so I was the engineering lead of University of Nevada's team for the 2013 one, and that was my master's project. So there was actually a lot of California schools participated in it too. I think SkyWorks Caltech was one team when we competed, and then USC was another team. And so how that competition run is that everybody's building a net zero solar powered house. But your house has to be special. It has to have a story, and then it's called Decathlon because it has 10 contests. So there are 1,000 points, and half of it is juried, half of it is measured contest. So you get juried on architecture, engineering, communications, cost, market, and then the other 5 measured category, including your temperature, humidity of the house, how well your house performed if it reached energy balance. And then, so the cool thing about what that competition, and I'll come back later how this related to robotics. The cool thing about what that really competition did is that it empowered students to really come out of the classroom and really get hands-on, because we had to build a house. Everybody has to build a house. So I spent 2 years really in not only whole house design, how to create energy efficient house, and learned what's actually the more important thing behind it is we ran our team as almost like a little startup. So we have my co-lead on that project was a Taiwanese girl, and she was in the architecture program. So normally, a lot of architects and engineers actually don't work together a lot of the time, side by side on house design. And for our house, because it was not extremely high tech, but it's really high tech. We had solar PV, we had solar thermal, we had home automation, and everything needs to be really integrated. So we worked, and everybody was doing this as a student at the time. So and everybody was taking classes. So it was a 2-year that's unforgettable, because we would go to class during the day, meet up at night, meet up every Saturday, and really work together in designing that house. And then 2013, during that summer, we had to build a house under Vegas is 120 degrees. So we end up actually winning 2nd place for the whole competition, which is 2nd place in the world. The only team that beat us was Team Austria, which is a European team that had a tremendous amount of support. They had a beautiful house too. But we won 1st place in market appeal, 3rd place in engineering, 2nd place overall and a lot of other prizes. And as a team and as a school, that's like a first-time competitor, it was just great pride, great reward. But what really that project on why it kind of transitioned later into the robotics startup that I'm doing now is that it taught me a lot of things about project management, about the business side of things. Because before that project, I was just an engineer. I was an engineer. I think the coolest job is probably go to Lawrence Berkeley lab and do research. But from that project, I understand, hey, to build our house, we have to fundraise. We had to fundraise, all the money that we actually get to build the house, and we actually had to fundraise, go out into the community to talk about what we're doing that's significant and what we're doing that's different. Because everybody is building the net zero solar powered house, you have to have a story to tell there. So for our house, it was actually a desert house. We talk about how creating a house for your own environment, for your own climate is a very different approach than just build like track homes. That was a specialty of our solar house. So that house eventually, after the competition, it got brought back to Las Vegas, and right now it's at a local park called Springs Preserve, and it's living on as a sustainability classroom. So if you're ever in Vegas, please go see it. Our pride and proud. So after that project. That was October 2013 when we competed, and I was like finishing up my master's thesis. And my buddy who I went to school with, in mechanical engineering, we actually first met in when we were both freshmen. So we kind of converged on. I went and did solar, and he actually went off and did robotics. He started building these quadrotors before quadrotors ever were popular, or heard of, in his garage. So throughout the whole 4 year of our undergrad, he became really an expert in building these, and then got picked up by one of our robotics professors to basically build aerial platforms for indoor radiation detection. So both of us were really entrepreneurial, and we're it's kind of towards the end of our school career. We both don't want to work for, just go out, get a job and, do HVAC design, this kind of stuff. And I just came off of Solar Decathlon, so he invited me to his lab one day to see his robot. And so I was joking with him, I've been seeing you building these for 4 years now, what else are you going to show me? And so I went to his lab, and he had this quadrotor that's made out of carbon fiber. And then he flew it, and it was kind of in the cage lab. He flew it, and it had a stabilized gimbal camera on the bottom and everything. And he was talking to me about what he was doing, with that platform for indoor radiation detection. And it was like a voila moment. I had to go back home and think a couple of days, on if I want to take on the project. Because the whole time he was like, "Oh, come be my CEO and start this business with me." And I was like, I was too busy doing Solar Decathlon, but I was like, "Oh, let me think about it a couple of days." So another thing that's really what kind of pushed us into doing a startup company is that as engineering students at our school, we always have a capstone project. So every student has to do a capstone project, and the whole point is commercialization. However, at our school, for some reason, all throughout these years, you get grant prizes, you get grand prize, first prize in mechanical engineering, electrical engineering, or whatever. But no high-tech company really spun out of that. So, and his project at the time was actually it was a capstone project. So I asked our dean of our College of Engineering. I was like, has there been any startup or high-tech company that actually came out of our capstone project? He was like, no. And for me, who anytime that it's a no or nobody has done this opportunity, I was I kind of jump on it. So honestly, that's how we started up. So I went back to Greg, who's my co-founder, and we're like, well, let's make this happen. And just happened to be the same time Nevada got one of FAA's 6 test site designation for UAS. So the drone industry is getting all the attention in the state, and we became one of the players. As a startup, there's a really cool story about how UNLV students are doing this, and so we decided, because both me and Greg are engineering background, that we decided to actually take a MBA class and work with our College of Business in creating a business plan to really move forward. So that's what we did, and we actually ended up winning the Southern Nevada Business Plan competition of last year, and then it gave us like a little bit of seed money. It gave us like $28,000 in like seed money, and a whole bunch of like in-kind services from accountants, legal, and everything. And that's how we move into our shop. And now, so the company has been running for a good 7 months, really. 7 months, like since last May. We have a little office, about 2,400 square feet, in Henderson, Nevada, and we have 6 full-time employees, a software, hardware engineer, and also marketing. And then we always kind of pride ourselves as one of the iconic robotics startup in Nevada, in Las Vegas. So I'm going to talk a little bit more about, like about drones, just in general, like what we do, like what we're passionate about. Mike said earlier, like when people say drones, everybody thinks of DJI. DJI, those toy, consumer, what we call like lifestyle drones that take pictures, take picture of your picnic or a house. And then there's also, of course, people are really familiar with Amazon's delivery drone, what they're really ambitious to do to deliver packages. We as a robotics company, since coming from like scientific background, what we're really passionate about is enabling the other senses of the robot itself. So, when we say, okay, like a human, right? Like we see, we hear, we feel, temperature and those kinds of things. We want to put that same kind of sense on the robot, and that's what we're passionate about, our drone technology. So what our drone really does, it's really more for enterprise and scientific applications. Like I said, it originally started as an indoor radiation detection platform, and we realized there's actually a gap, or like where scientists and researchers, they want to develop these different applications. They see the potential of an aerial platform, but there's no good platform for them to develop peripheral payload design or other kind of sense of the robot on. So let's say for DJI, right? Like they have to take off the camera, they have to go hacking the hardware. You can probably buy it through the Iris, that flies a little bit better, but it also has a kind of a limit capability. And then on the other side, the FAA's there. The FAA's there, they're saying, you can't fly these commercially because, hey, how are you going to show me the reliability of the platform? And so there's a lot of just barrier in really putting the aerial robotics techniques into a lot of the great industrial applications that could be done. So we kind of modified Greg's original design from his senior design and really create a platform that's easily to develop on. So let's say you're a researcher in agriculture. All you care about is, how to use multispectral sensor to see if your plant is sick, and then how to manage your crops, the water and those kind of stuff. They are not robotics experts, right? So a lot of them, kind of go out and buy some kind of platform, merely building the drone out of necessity because that's what's out there. So we basically design our platform in a way that it's easily to develop on, to really develop sensors on. So we actually so just even so that was kind of our original philosophy. And also what made us unique is that we have the kind of hybrid design. So coming back on the FAA part, how reliable your flying platform is, we sealed all our flight worthiness in our brain, in the brain of our aerial platform, so that when you are developed on it, let's say you don't have to go into the hardware of what connects to the flight worthiness of the aircraft itself. So that's all sealed in one box, and then there's a bus on the outside where you can just put sensors on, put rapid prototyping, see if it works, and develop and move on and move on. So and also it's since coming from engineering background, as a startup, what we find out is that the manufacturing of these is quite challenging. You need a lot of capital to really figure out the manufacturing side, and that's why a lot of hardware startups didn't succeed, or there are barriers at it. So originally we were looking at, okay, we might have to spend like 50,000 of our raised funds into like creating molds for these kind of parts, and then we were like, it's just, we didn't even know like if that design, how, like if it really works, right? So what we actually end up doing is adapting lean manufacturing. So right now our airframe is actually all 3D printed, and we can do iteration almost every airframe. So we like, let's say this month we sell 4, and by the one in R&Ds, these with these kind of slats or these kind of geometry, and really enable us to move really fast in innovation. In not only just and fast production. So people can come to us and say, we want a drone, and how soon can you get it to me? We don't have to wait until like, okay, we have to wait to create a 100 order for us to actually move on to manufacturing. We can just do one-off and just-in-time manufacturing, and enable us to really stay at the cutting edge of our own development. So those are some kind of like unique just engineering aspect. What we have to go through in the last 7 months, we have, right now we're in our early adopter program. Most of our customers are actually researchers and universities who really, liked our platform, the open development side of things, and just, it's a really high performance platform that's, once you fly it, you understand it's very different, than the DJI ones, and you can only see, right? Like ours can, if you want to, one of the professor we work with, he says it's like radiation, it's like electronic nose. So it senses like radiation sources by triangulation. So he's developing like algorithm on using radiation sensors and triangulate, like radiation sources by using these aerial platforms, which is really valuable for, let's say, a scenario in nuclear power plant. You don't, like instead of sending in a technician all suit up, probably all suit up and have to, use a handheld device to detect like where all the radiations are, you can just use this kind of platform and collect data autonomously. Who was at the Geek dinner last night? Anybody? Oh, hi. So one thing that, the dinner last night was about big data, and I was actually in a big data workshop at UC Berkeley about, I think, 5 years ago when I was in freshman. And one thing that, we talk about why big data is valuable, it drives decision making and all those kind of stuff. So when that ties back into drones, I also has some kind of relevance with robotics, is that it's not like statistical quantity analysis never existed. I mean, kind of data-driven analysis is kind of always obvious, but the reason why it just became really popular is because the cost of collecting data came tremendously down, and the ease of that, right? So, so this is part of what drives that, is that, let's say, I'm going to go back to the radiation example because that's kind of like a no-brainer. It used to be all these sensors are handheld, and you have to deploy each person, in this area, and this person probably can't even go to some of the really hard to reach spots to really collect those data. But robotics techniques, especially aerial robotics, is what really enabled that, and then brought the cost down, because now you're, like some of the technicians probably, $120 an hour or whatever, probably even higher. And now all of a sudden you can just deploy a robot to collect those data, and that brings the cost down and really enabled big data to be collected and then analyzed and everything. Because the analyst part, the people are always there, but collecting data just really cost prohibitive in the past. So that's what we're passionate about. We're passionate about, kind of scientific and industrial application side of things. And of course, I'll let everybody ask about all the questions you have for drones in the industry. We've been in it for a year. We've seen a lot of up and downs. We've traveled to all different places to do business. And part of what I'm really excited about where the space I'm in is because there's just every time we visit a new place or talk to new people, there's all like new applications that's being brought up. It's really exciting. It opens our eyes because, and it's just very exciting. So I think last week we were in North Dakota, and North Dakota is really big on agriculture. They have my 3 words, for North Dakota it was white, flat, and cold. It was about, when we got there, it was like, I think -3, and in Vegas it was like 70, right? And over there they have just fields of crops, and they really want to use UAV techniques to help with crop management. And it's kind of a no-brainer, but of course, there's a lot of regulation things they have to go through. But also what we found out, so part of what our platform also, one of our peripheral capability is IR, so it's thermal imaging. So when we brought it up to them, and they were like, oh yeah, we can use that to detect the temperature of our cows. And it never struck us because we're not agriculture experts, but then they were talking about how cows, like when they are sick, of course, the temperature is higher, but before they become pregnant, it becomes hotter. So they want to quarantine those cows, and then also, maybe relate that to like RFID, those kind of stuff to basically do better management and figure, and it's called precision agriculture. So they were really big on that kind of application over there. And then we also just recently, like we went to Oak Ridge National Laboratory. And Oak Ridge is really, since they're a nuclear background, they were really interested in our just indoor radiation detection, that kind of application. It's like, oh wow, can you fly this sensor? Can you fly that sensor? Yes, and we tell them, part of our passion is to make any sensor fly. And also because Oak Ridge was really interested in our lean manufacturing kind of approach, how we make our airframe, and we were telling them that it really enables little startups like us can do hard work, because a lot of the sunk cost into the capital investment into tooling and machines just all of a sudden it becomes zero when you adopt our method. And what else? And I think we also work with our local law enforcement a lot. Law enforcement, they actually are really paranoid right now because they're, when I talk to one of the captains over there, they're like, if you have a drone that's, let's say in a New Year's Eve, Las Vegas, that kind of scenario, and you have a drone that's flying around, right? And honestly, it's like illegal because you are within 5 miles of the airport, and until you find the pilot, there's no way you can take that drone down. What are they going to do? So they have those kind of concerns. So and so from law enforcement side, of course, their job is to protect public safety, and how do you migrate that? For them, their concerns, how until I find that pilot, which in a sea of people, how do I do that? So we're working with them actually on like cyber security techniques in doing kind of GPS tricking, like GPS spoofing, to trick that drone into thinking it's at its wrong coordinate and almost kind of arrest that drone and fly away. Of course, a lot of those in development, but those are kind of the idea right now in just so many different applications that people kind of never think of. With that said, I think I can open up the floor to questions.
Nice job. Okay, so we're going to do Q&A. John will walk around with the microphone. If you got a question, I see Graham there eagerly raising his hand. Raise your hand, stand up, say your name, what you do, and ask away.
Hi, my name's Graham. A couple of questions. First of all, battery life, in terms of how long can the drone stay up there? That's obviously something with your experience in solar, you've probably got some insight. The other area is, with the sensors, are you actually storing in a multiple of the applications from what you've seen from customers, the data on the sensor and retrieving it when it comes back, or are you doing real time? And if so, how do you encrypt that data at this stage, given how sort of power absorbing the existing AES type encryption codes are?
Mm-hmm. So for our system, we pride on our what we call UAS architecture, is that we have triple redundancy in data storage. So some data is going to store on the aircraft itself, but we also have our what we call ground control station. So when there's the data is going to be parsed onto the ground control station, and it has like a mini computer running in there that's going to store some of the data. If it has connection to the internet, it can back up to cloud. So talking about that, the one thing I do want to mention, also kind of take away from our North Dakota trip, was that there's a lot of company that's really ambitious in doing solely LTE managed data backup, those kind of software side of things. And for us who have LTE network and kind of take granted of that, like it's kind of obvious and we don't even think twice about it. However, when we're in North Dakota, we found that, hey, there's no network there. There's stuff is not going to work. So there's a lot of actually we're right now working with Intel on a project. Basically, it's kind of more like local. They call it not cloud, but more like fog. So more like local deployable kind of network if they want to do big area of crop management.
Okay. Hi, my name is Lin from JPL. I have a couple of questions, actually, two questions. First is, drone we know, is pretty mature technology, so what are your competitors? Second is that how you just guarantee you have a very small engineer team, how to guarantee the reliability, because as you mentioned that you want to send a drone into the nuclear plant. I'm not sure if they have done that already. I guess there are a lot of safety issues there. So how do you make sure that this can be done in a reliable way?
Yep. So those are definitely, a lot of those are definitely on our wish list and on our to-do list, I would say. And like I said, our company is only 7 months old. So it's not, we're not saying, a lot of those things we have it figured out already. But those are definitely, on our docket list for, issues we want to attack. And that's what's going to separate us. So let's say, when people ask us the difference between you and DJI, well, ours can go into nuclear power plant. So that's why we actually went to talk to Oak Ridge National Laboratory to see if we can leverage some of their expertise on the, material side, electronic side, how to shield our electronics, and we have to figure out, which part's going to fail, in that kind of environment first. And also, on the 3D printing side, the beauty of it is that you can create custom blends instead of just, like a regular. There's a lot of things you can do with the material side for different applications. So let's say if you need a high temperature one, if you need a cold temperature one, never thought of that until we went to North Dakota, and then it becomes a really dynamic platform. So the geometry can stay the same, and so we're basically partnering up, collaboration, leveraging their expertise on the material side for these kind of more enterprise industrial kind of applications and make us unique. And also cybersecurity is definitely one thing that's going to set us apart. What's that? Competitors? Oh, who are our competitors? The competitors, what we have find. So, I'll say a couple, like the ones that I mentioned earlier, like DJI, like 3D Robotics. So DJI really targets consumer market, consumer market. And of course, there are a lot of toy drones we don't, those are just toys. And then on the higher end, there's like Dragonfly. There's Dragonfly that is mainly their customers are law enforcement, and they're really expensive. They're like about $50,000, and all it does is really carrying a camera. So for us, we kind of pride ourselves at the price point, but really dynamic that can carry different sensors. So for a competitor, it's sometimes it's hard to say because there's industry specific and there's capability specific. So are you more interested in let's say in the law enforcement area, like who are those players, or like capability wise, For science? Yeah. Oh, okay. We have found out that there are not a lot of people doing scientific applications. That's kind of where our niche is. That's where because the bigger players like Lockheed Martin, they have their own UAVs, and they are mainly targeting military contracts. iRobot has a UAV that's tethered. I didn't answer the battery question. It has one that's tethered as opposed to supply infinity power because it's tethered. And they are also going after military contracts. So we have find ourselves kind of in this kind of niche place for scientific applications. We haven't found anybody who designed specifically for open development.
Hi, I'm Pat. I'm an engineer, so I'm a little familiar with gee-whiz engineering and stuff. During my undergraduate work in the 60s, a full 30% of the coursework was in the humanities. That was required for my engineering degree. Now, I'm aware that drones have a bunch of Ds attached to them. They do jobs that are dull, dirty, dangerous. And recently there's a fourth D that's been added of detached. Mm-hmm. So a drone doesn't have to, it can make detached decisions that a human might be confused by. Drones perhaps aren't as discriminating as humans. And some people are talking about doomsday, so that would be the fifth potential D. Can you tell us a little bit about the state of ethics training for engineers at UNLV and how that gets incorporated into your work?
Ethics. So, so UNLV just started a UAS minor. And the whole minor is, a lot of it, it's really more of a teaching students all the peripheral knowledge, on how to get your platform through a, COA certified process, all these kind of stuff. I mean, when you mention ethics, are you talking about ethics in the design or ethics in the use?
Zyklon B was used by the Nazis in their death camps, and some of the medical personnel and engineers that provided that information to the Nazi regime were executed as a result of the Nuremberg trials. So that's an extreme example of an engineer or a designer bearing some personal responsibility for the consequences of the work that they do. So that would be engineering ethics. Is it a required course at UNLV? And how do you see any drone manufacturers? I mean, I was thinking about this earlier. You could have a lighter than air drone in the workplace, right, with helium and stuff. Mm-hmm. and it could randomly taser employees, which might give them an idea of the consequences of drone use.
So my earlier example of how to use like GPS spoofing could be actually a kind of good example. Everybody can still hear me? So when that technology was first developed, right? It basically you have a drone and then you have another drone that can GPS spoof that, and you can take that away. Now, in use for, let's say, if the police is using it, they're using it to, let's say, arrest illegal drones. Like ethic-wise, that's kind of good use. But you can actually also, it could be a terrorist kind of, application. If you got a hand, in the technology itself, you can actually go hijack you can hijack the drones really easily. And actually, that's what what we did to what Iran did. There's some like articles on that. So I think ethic-wise, definitely is it's a topic. Not only engineer and to answer your question earlier, yes, we have the class. Every engineer has to take it. It's Philosophy 242. It's taught by a philosophy professor, but there I personally, think it probably should be taught by an engineering professor sometimes, so it's more relevant. But anyways, that's curriculum. I don't have control over. But yes, so part of the question, is that course required? It is. Not sure at our other engineering schools, but also I think it's more of a user. I think it's more of a more user-related topic.
Hi, I'm David. The thing I was really fascinated by when you were talking about going to North Dakota was the cow temperatures. And as a non-technical person, but an artist, I just wanted to see those images. And I'm just wondering if there are any artistic applications that are being applied to drones, and if there's anything you're exploring at all.
Artistic applications, well, Hollywood. Those are. I think once those images are done, and an artist will probably take that, to the next level if they wish, and that could be actually a really cool spin-off of digital art.
This is gonna be the last question.
Cool. So I'm Molly. I'm in biotechnology, so I don't know anything about this. But I love what you've done, okay, because you've found this really cool niche. And so I'm wondering how you're going to achieve, world domination, right? so how, here you are doing all this cool stuff. As a biologist, I can imagine, oh my gosh, all the ecologists would love this if they knew about it, right? And so how are you going to get out there and avoid competition?
I think definitely coming to an event like this and talk to more people about us, what we're doing, is definitely going to help. And we find the academic environment's like really tight. If we kind of get in front of one professor and that researcher likes it, they'll tell all their other buddies about it and stuff like that. So we're trying to take that approach. Right now our team is really small, so we can't really. The challenge of selling stuff that's kind of scientific is that you can't just get a salesperson to do it because they don't really can't talk tech about it. So basically, the sales force right now for our business, me and my co-founder, and but we've been enjoying it so far and just talking to. What we do is we kind of see an opportunity and we go to conferences, either at that conference or talk to professors and then approaching it that way. And then we're also, our end goal is really, become robotics company that not only do aerial robotics, but, maybe also like a ground-based stuff. One of the really niche thing that we do in Nevada is underground mining. It's probably not big here in California, but if you think about it, when mines there's kind of two applications. One is abandoned mines that everybody's scared to send anybody in. You don't want to endanger a geologist's life to see if the structure, like those is safe or not. So, you can actually send in a drone and take some images and figure out the weak spot and stuff like that. There's another application where before you send in a first responder, there may be like a pocket of toxic gas. So hazardous material detection is, something that we're really passionate about, and underground mine is actually a really niche application where FAA has no say-so because it's not in their airspace, that we're legally actually able to shine the technology, without going through all the process and be able to detect, methane pockets or those kind of stuff, like before you're sending a first responder. Thank you.